Welcome friends. So continuing from previous lecture, we have got the concepts of SUID, SGID and sticky bit, and now we are going to implement that. Let's start off with this command, which is pwd, which shows that where I am at the moment. And I'm in home Ahmed lpic1 folder. So I'm in my home folder and further into this directory. Now before I execute the commands, let me also show you one interesting thing. If I put in, let's say ls minus l and then bin and after that ping. Now you see that this ping and also compare this command with, let's say, another command which is maybe ls. Now you see the difference between the two outputs. Of course, I mean, if we look at this one, we can spot that instead of this executable over here, we have got this small s, and now we know what this small s means. But look at this one, look at this. This has got red color. I'm using Ubuntu and other distributions show of colors like that. And this red color, it kind of signifies that this command, be careful. It's kind of warning that this command is being run with the credentials of the root. Similarly, if we have a look at the contents of or the file permissions of password, which is in, I believe, in user sbin. So user sbin and password, or it's in sbin. So sbin and password. Okay, so it's not there. Let's do the command which to find it. Which and password. It's in user bin. Okay, so it was user bin. So I type in user bin and password. And again we see that both of these commands are owned by user root. Their group ownership is also root, but their sticky bits, pardon me, not sticky bits, their SUID bits are set and both of them are turned red. It means that be careful, these commands are being run with the credentials of the root. So now let's try to set our own SUID permissions on the files. If I do ls minus l over here, and let's just see the contents of this file1 by typing cat file1. So I have put this small script which does not do anything except that it prints hello world. And at the moment, this file1, it is not executable even for its own user. So if I try to run this command by typing in file1, it gives the error which it showed. So let's try to change the permissions of this file by change mod 764 and then file1. And now if I try to run this command, we get the output which is hello world. Now let's change the file permissions or the ordinary file permissions to 777. Or that everybody should be able to read, write and execute. Let's just do that and have a look at the permissions now, and we see that indeed its color has also been changed to file1 because now it has become executable, and we see that all the permissions have been set to read, write, execute. Now let's open up another terminal, and let's say in that terminal, let's just bring them side by side if we could, so that it would be easier for you to see. And let's say let's change to user Tom, which is another user on this machine, and I put in the password, and now if I type in who am I, we see that now I'm user Tom. Now let's try to execute this command. So I type in home Ahmed and lpic1 and after that file1, and indeed it gives the output as hello world. But now this command is being run with the credentials or the ownership of the user who is running it, which is Tom in this case. If we want this file to be run with the credentials or the ownership of Ahmed, then we need to set the SUID bit set on this file. And we can do that by typing in change mod u plus s and then the file name, which is file1. Now once we do that, we should ideally see that its color will get changed to red if we type ls minus l and we see that indeed its color has been changed to red. Now as far as the execution is concerned, because this does not interact in any way where we can identify, but the examples that I told you earlier, which were ping and password, that were pretty good examples to understand the underlying concept of SUID. So if we try to run the command again, the result is the same, but you can clearly see that the color has changed and also the bit has been set. Now let's try to see the SGID bit, how we can do that. So I'm here, and let's try to create a directory. Let's call this test SGID. So that's the directory that I've created, and let's also change the permissions of this directory to be 777. So I type in change mod, and afterwards I type in 777, or maybe for recursively for all the directories and subdirectories that are in there, I type in -r and then 777 and then the name of that directory, which is test SGID. So once I do that and I do ls-l over here, we see that indeed there is this directory SGID, test SGID, and all of its normal permission bits have been set to 777. Now let's come on to this side where we have got this user Tom, and let's try to get into this directory, which is home Ahmed and then lpic, and in that directory which is test SGID. Now indeed we can get into it because the permissions have been set to 777. And also let's try to create a file. Let's just call it touch and tom1. So it says that no touch1. Did you mean touch? Oh, my spelling. Wow. So touch and tom1. Okay, the file is created, and if I do ls-l, we see that this file, whose owner is Tom, because of course Tom created it, this file's group membership also belongs to Tom. But now let's do one thing. Let's try to change the group bit for this folder. So the way to do that is pretty simple. We just type in change mod g plus, or this time use the numerical value. How about that? So I type in 2 and then 777 and then the name of the directory, which is test SGID. So once we do that and we do an ls-l, we see that now in group portion of the folder, we see that executable bit x bit, it has been changed to s bit. So it means that now all the files or directories that are created in the folder by any of other users, they will have the ownership permission or the group ownership permission of the owner of the folder, which is in this case Ahmed. So let's just come over here and let's try to create another file. Let's say tom2, and let's do an ls-l. Now you can see the change that now the group membership that this tom2 file belongs to, now it is Ahmed. So pretty cool stuff, isn't it? Some really good things as far as permission is concerned, and from security point of view as well, and sharing things as well. Now coming to the last part, which is sticky bit, which is in fact kind of implementing a security on the folders. Let's just say we have got this test SGID folder again, and what we want to do is that since this folder belongs to Ahmed, if Ahmed creates any file in there, these files should not be deleted by user Tom. And before we do that, let's just try to do one thing. Let's create a file in there. So let's just get in there first by typing in test SGID, and let's create that touch Ahmed1. Now once we do that and we look at the contents of this file over here from user Tom, we see that indeed Ahmed file is there, but Since the owner permissions, since the normal permissions of this folder, this test SGID folders are set that anybody can change the contents, maybe execute or delete the files and folders in there, then this user Tom, he should ideally be able to delete this Ahmed1 file. So let's see if we can do that. I type in rm Ahmed1 and I press enter, and it is asking that whether I want to delete or not. I press Y and I press enter, and if I do ls-l one more time, we see that indeed that file is gone. So that's a bit of a problem for user Ahmed, because Ahmed wanted this folder to be shared by other users, but he did not want his files to be deleted by other users. So what he can do, he can set the sticky bit on the folder so that users can create files in there in a mixed environment, but only the owner of the file should be able to delete the file. So to do that, let's just try to put in the command, which is change. Let's just first get out of this folder, testing SGID, and put in the command, let's say change mod, and let's try to put in 1 and then 777 and then the name of the folder, which is test SGID. So I press enter, and this time if we have a look at let's say ls-l, we see that this time the other portion of the file permissions, their executable bit has been changed from X to T, small t. And if we come over here one more time, but before doing that, let's just do one more thing. Let's just create this file again, touch Ahmed1, the file has been created, and if we come over here, that file, oh, I did not go into that particular directory. So let's create it one more time. We are here, and if we do ls-l, we see that indeed Ahmed1 file has been created. Now, since this sticky bit has been set on this folder, and the purpose is that only Ahmed should be able to delete his created files, so Tom should not be able to delete now. Let's see if he can do that. Let's just try to remove Ahmed1 one more time and press Y and enter, and we see the message that operation not permitted. So really a good way to share things among different members or different users on a Linux machine, but also kind of protecting your content and folders. Well, that's all there is to it. I hope you have learned from this video, and I would like to thank you for viewing.